Welcome to this video. So today we'll be looking at questions on chemical kinetics. So we have 5 questions in this tutorial sheet. We are going to solve all of them. Okay, so I'll be explaining the concepts as we solve these questions that you can see here. So let's start. Okay, so question 1 is they're saying for the reaction, okay, 2A plus 3B, which produces 4C plus 5D. If the reaction in terms of the change in B is given by 6.69 times 10 to the power minus 2, what would be the rate, okay, in terms of the change of D? Okay, so here before we solve this question, allow me to explain the concepts that we are using. Okay, so suppose I have a reaction, okay, let's say A plus B, okay, is producing maybe C. Okay, and then let's say at time 0, okay, the concentration of A is 5. Okay, the concentration of A is 5 at time 0. And then the concentration of B at time 0 is, let's say, 3. Okay, and then the concentration of this product, of course, at time 0, it would not be yet formed, right? Okay, no product has been formed at time 0. So it means the concentration of this product, C, at time 0 would just be 0. Okay, so now suppose that we have moved to time 1, and then the concentration of this A at time 1, okay, has reduced to 3. Then the concentration, okay, of B at time 1 has reduced to 1. Okay, then what do you expect this concentration of C to go to? Okay, so the concentration of C at 1 will just be what? 2. Okay, because all these are reducing by 2, so meaning this one is going to increase by 2. Okay, so now when you want to find the rate, okay, at which this reactant here is being used up, okay, you say the rate, okay, is equals to the change in the concentration of A, okay, divided by the change in time. So the rate, the change in the concentration of A is equals to the concentration at the time 1, which is the new time, minus the concentration at the time 0. So that would mean that I have 3 minus 5 divided by the change in time. So here, where the concentration is 3, the time is 1. Where the concentration is 0, the time is, where the concentration is 5, the time is 0. So what I end up with is minus 2, okay, over 1. So this is going to give me that the rate, okay, of change of this A is actually minus 2. But we know that the rate can never be a negative number, okay? So in the formula for finding the rate of a reactant will always be including a negative in front there, so that this negative comes and cancels out with this negative that we find, okay? So it means now this will just be a positive if I have a negative there. Okay, so that's what we'll be doing. We're going to find in the rate of a reactant, okay? The rate of a reactant, the rate at which it's disappearing. We're always going to put a negative in front. So it means I can write this guy somewhere here. So I'll say the rate, okay, at which this reactant A is being used up is just equals to, since I've put a negative there, okay, I'll put a negative, and then in front, in the brackets, I'm going to put this minus 2 that I had found just for this part here. So this part here is equals to the minus 2. And then I put this negative so that I just cancel out that negative, so that the rate there is actually positive, because the rate is always positive, okay? So it turns out that when we find also the rate, okay, of this reactant B, it will be minus the change in B, okay, divided by the change in T. So that will be the same because this will be 3 minus 1 over 1 minus 0, which will still be what? So which will still be minus, and then the minus inside there. Oh, this is 1 minus 3, not the other way that I've written it. Okay, because at time 1, the concentration there is 1, and then at time 0 is 3, and then the time is 1 minus 0. So we get minus, this minus outside here, and then the difference there will be 1 minus 3 minus 2 divided by 1. I still get minus 2. So I'll also write it here. I'll say the rate. Okay, for the reactant, I should use another color there because there's something that I want you guys to see. So the rate of change of this concentration B, okay, is actually equals to, okay, is actually equals to minus 2, which will just give me a positive 2. Okay, but now look at it. Look at this, I mean, okay? When it comes to the product, if you're finding the rate, to just be straightforward, okay? So we're finding the rate of this, we're finding the rate of formation of this product C here. So it will just be the change in concentration of C divided by the change, okay, in time. So at time 1, I have 2 as my concentration, okay? Or at the final time, my concentration is 2. And then at the initial time, my concentration is 0. And then the change in time is 1 minus 0. This just gives me 2. Okay, so for the product, it works out naturally. Okay, if you find the rate of the formation of a certain product, it's just going to give you a positive rate. Okay, there's no need to include these negatives that we are putting on the reactants. Okay, so the change in the concentration of C over the change of time is just simply equals to what? To 2. Okay, so here it turns out that these numbers that we found here, they are the same because the coefficients, okay, the stoichiometry coefficient of this reactant and the product that was formed was 1 here, 1 here, 1 here. No wonder we're finding all the rates to be the same. Okay, no wonder we're finding all the rates to be the same. So now in general, if you want to find these rates, okay, I'll just write a general formula. In general, when you want to write this rate, okay, and then the reactants and the product have a coefficient that is not 1, you're going to have something like this. Okay, so I'm going to have A plus B, which is producing C plus D, but now these reactants have these coefficients like this. Okay, so to find the rate here, I'm going to say rate, okay, of the rate at which this reactant is being used up, okay, it will be the same thing that I wrote, the change in reactant A over the change in time, okay? But now we're going to multiply this guy here, okay? Remember there was a minus there, so I'll put the minus, and then I'll multiply by 1 over A, okay? The coefficient there. And then this will be equals to 1 over B for this guy, and then the change in the concentration of B over the change of T. And this will be equals to, I go to the product side now. Okay, so the product side, it will be 1 over C, the change in the concentration of C divided by the change in time. And this will be equals to 1 over D, and then the change in the concentration of this D divided by the change of time. So this is a general formula that we can use, okay, to compare the rates of the individual reactants and the products. Okay, so this simply means that if I am given one of these, okay, if I'm given one of these rates here, I can be able to find the rate of the others. Okay, so let's say I'm given the rate, okay, of the formation of a product. I can use this because it's equal to this guy to find the rate at which the reactant is being what? Used up. Or if I'm given this, okay, the rate at which the reactant is being used up, I can actually use it using this equation, okay, because all these are equal, just like all these twos were equal there, okay. I can use it to find the rate at which the product is being what? Is being formed. Okay, so this approach here is what will help us find the answer there. Okay, so let's take the equation that we've been given down there and write it in this form here. Okay, so I'll say there I have 2a plus 3b, and then this gives me, okay, or maybe I can use the one which is just on top there. Okay, let me just erase some things. Okay, so I can erase these guys. Oh no, I'll need them to show you something. Okay, so now what I'm going to do is that I'm just going to erase the A, erase the B, erase the C, erase the D, and then put in the actual numbers there. Okay, put in the actual numbers. So that formula there, you should memorize it. So now I'll put in the actual numbers. Here I have 2, here I have 3, here I have 4, and there I have 5. Okay, so it means here I'll divide by 2, here by 3, here by 4, here by 5. Okay, that means that is what I have there. Okay, so now they're saying for this reaction, this one here, okay, if the rate of the reaction in terms of change of B, so they mean the rate of change of this guy here, okay, if the rate of change of this guy, change of B over change in time, okay, if this guy here is equals to 6 point, okay, 6.69 times 10 to the power minus 2 ms to the power minus 1. Okay. Okay. If this is what has been given there, okay, find the rate of change with respect to D. So we've been given this one, which is a reactant. Okay. And then we want to find the rate of formation of a product. So we're going to equate this part here, okay, and this part here for the product, because they're the ones that are of interest. So now notice that when we are finding the rate, okay, of how the products, how the reactants are used up, I was finding a negative. Remember? Okay, so the change of A with respect to T had found a negative. And then I said to make it positive, we always add a negative in front. Okay, so it means here the rate of change of B, because it is a reactant here with respect to time, it has to be negative just like that. Because when you're using the products, okay, if you start maybe with 500 as the amount of the of the reactants, I mean, not product. If you start with 500 as the amount of reactant, as the reaction progresses, okay, those reactants are being used up, right? Okay, so it means the concentration at a certain time will be less than the concentration at time 0. So when you subtract them, you always get a negative number. And then when you divide by time, you actually get a negative number, just like we got these two. Okay, so the rate of change with respect to B over time will be actually this same number here, but with a negative in front. Okay, so now we can equate this guy, and then solve for that guy. Then we are done with the question. Okay, so let's do that. So I can erase this part which is not necessary. Then I just write the part which is necessary. So the part which is necessary is 1 over 3, and then rate of change with respect to B over rate of change with respect to time. And then I'm going to equate it with my interest, which is 1 over 5. Okay, rate, I mean change of D, okay, and then change of time. Okay, so that is all that I need. Okay, I've explained what we are doing there. So now here, I'm going to say I want to find the rate of change of D with respect to time. So I want to eliminate this 5 in the root, in the denominator, I mean. So I'll multiply throughout by 5. If I multiply this by 5, it will be 5 over 5, so that will become 1. So it will mean the change of the product D with respect to time is equals to, if I multiply this 5 with this, I'll have a minus 5 over 3, and then change of the reactant B with respect to what? To time. So this is just going to be equals to minus 5 over 3, and then minus this guy. I mean multiplied by this guy. So what is the value of that guy? Okay, it is this value that I wrote here. So I'm going to multiply by minus 6.69 times 10 to the power minus 2 ms to the power minus 1, like this. Okay, so I just get that now and multiply it on my calculator to see what I'm going to get. So I have -5, okay, -5 divided by 3, and then I multiply by -6.69 times 10, okay, to the power -2. Okay, so when I multiply that, what do I end up with as my answer? Okay, so I am getting 0.1115, and this is just ms to the power -1. Okay, so here this guy will be the rate, okay, at which D is being formed. If you want, you can represent it in scientific notation. Okay, you're just going to say, let's move this decimal place 1 point, okay, to the right. So that would be 1.115, okay, times 10. And then I moved to the right 1 time. So I put -1 there, then m is to the power -1. So that would be the rate of change, or the rate of formation of what? Of D. Okay, so if you are given just one of these, you can see that we can calculate any other, as I have illustrated here. Okay, so that's nice. So we go to the second question, which is this one. Okay, so here they're saying a scientist conducts an experiment to determine the rate, okay, of NO formation in the reaction below. So this is the reaction there. Okay, if the initial concentration of N2 or nitrogen was 0.5 molar, and the concentration of this nitrogen was 0.450 molar after 0.1 seconds, what is the rate of formation of NO? Okay, so first of all, we write the balanced chemical equation. Okay, this guy is already balanced here. Okay, so if I was to write the general rule here, it would be that the rate is equals to, this guy here has 1 as the coefficient, even this one is 1. So it will just be minus the change, okay, in the concentration of N2 divided by the change of time is equals to minus, okay, 1 over 1, still 1, the change in the concentration of the oxygen divided by the change in time. And this will be equals to 1 over 2, because I have a 2 there in front, okay, the change in the concentration of NO divided by the concentration of what? Time. So here we've been given that, okay, we've been given that the concentration, okay, we've been given that the concentration of, we've been given that the concentration, okay, of N2 at time 0, meaning initially, was 0.500 molar. Okay, and then after time, 0.100 seconds, okay, the concentration now is N2, okay, at this time, I'll just write T, being represented by this, okay, is actually equals to 0.450. Okay, so we can actually find the rate at which this reactant here is being used up. So we can find this part here. Okay, so that's what we're going to do. I'm going to say the change in the concentration of nitrogen divided by the change in time is equals to the concentration of this nitrogen at time t minus the concentration of this nitrogen at time 0. So this will just be equals to 0. Oh, I forgot to divide by the time. So the time here was 0.100 minus the time there was 0. And then this will just be 0.450 minus, okay, 0.500 divided by, this is 0.1 minus 0, it's just 0.100. Okay, so when I punch this onto the calculator, what do I get? Okay, so I'll do it 0.450 minus 0.500. Okay, and then that divided by 0.1. So I get minus 0.500. Okay, so that would be molar second to the power -1. Okay, so this one here is actually my rate of the nitrogen being used up. Okay, so now the question was asking me about what is the rate of formation of NO. So they want me to find this guy here. Okay, that's what they want me to find. So I'll just equate this part. Okay, I'll equate this part here, this whole part here, to this part for me to find this, since I know the value of that one here, which is what I found there. Okay, so let's do that. Okay, so when we equate those, it will be minus the change in the constitution of N2 over change in time is equals to 1 over 2 rate of change of NO over rate of change. Okay, so this value now is minus 0.5. So I'll say minus and then minus 0.500 is equals to 1 over 2 multiplied by the change in concentration of NO over concentration of time, which is the rate of formation of this guy. So I'll just now multiply throughout by 2. Okay, if I multiply here by 2 to be 2 over 2, this would just be 1 and it will leave me with what I want. Okay, so that will give me the rate of formation of this NO, okay, is just equals to this negative multiplied by negative. I get a positive 0.5. And then positive 0.5 multiplied by 2, I just get 1. Okay, I just get 1. So the answer there will just be 1.00 molar second to the power minus 1. Okay, so this is the rate of the formation of the what? Of the NO. And we're done with that. Okay, we're done with question 2. Thank you so much for watching this video. Okay, if you'd like to access more videos on tutorial sheets and past papers, feel free to register with us. Okay, so in the description below of this video, you'll find 3 links. One is a registration video guide. It will guide you on how you can make an account and then register with us, okay, to access full tutorial sheet videos and full past paper videos, as well as topic what? Lessons. Okay, the other link is for the website, and the other link is for our mobile app. So on our mobile app, okay, you can actually download these videos and watch them offline. So you don't always have to use bundles when you are learning on our platform. You can easily get the mobile app. Okay, so just go on Play Store and then you search Discrete Learning Institute. The app will come, you install the app, and then on the app, you can download the videos and watch them offline. Okay, so check out the video in the description to know how to register. Once you register and then you go on our website, you're going to see something like this. Okay, so it depends with whatever you want. So if you want math, you register for math. If you want chemistry, you register for chemistry, just like that. Okay, so for example, if I open the course chemistry here, you want to find 2 folders. Okay, so if you're in semester 1, you go in the general chemistry here. Okay, so if you're in semester 2 Apex, you go in this folder. So semester 1, I'll open the general chemistry there. Okay, I'll find 5 folders. So this one here is for lessons and tutorials. So whatever topic that you're going to learn, okay, we have lessons in video form as well as summarized notes on all the topics. So you can see here all the topics, okay, from introduction to chemistry all the way to nuclear chemistry. We have the videos here. So you can watch these at your own time. Okay, and learn at your own pace, anywhere, anytime, even in your blankets. So here we have the handwritten summarized notes, so you can check them out. And then here we have the tutorial sheets. There we have the past papers. Here we have the lab report samples. So if you want to check out the past papers, okay, you open this folder and then you go to your university. So for example, if I'm at Apex, I'll go in the Apex folder. Okay, and then I'll go to the video solutions there. If you want, you can check out the written solutions. We also have them. Okay, so the video solutions, you're just going to find videos on different past papers. Okay, it can be quizzes, it can be tests, as well as the final exam. You're going to find the videos there. Okay, so these are the videos there. You can see some of them are for the exams, some of them are for the tests, some of them are for the quizzes. So you can use all these videos to learn at your own time, at your own pace. Okay, so these are the past papers. If I go back here, okay, if I go back here, I can now go to the tutorial sheets and assignments. So it's the same thing. You go to your university. So let me give an example. If I go in the Apex folder there, you're going to find different intakes. So you select the intake that you are in. Of course, you can also use the videos for the other intakes to learn, okay, because the concepts are just the same. So here I'm going to go into 2025 July what? Intake. So when I go in this folder, I'm going to find the video solutions to all the tutorial sheets that we've had so far. So these are the tutorial sheets here as well as the assignments. So the assignments, we have full written solutions, assignment 1, assignment 2, plus the video for assignment 1 here, the video for assignment 2 there. Okay, and then there are this tutorial sheet. This is 1, 2. Tutorial sheet 2 is divided into 3 parts. There's question 1 to 3, question 4 to 6, and question 7 here. Then I have tutorial sheet 3, 4, 5. This is supposed to be 6, but on the tutorial sheet they wrote 7, and then this one is tutorial sheet 7. Okay, and then from there we move to tutorial sheet 9. We had no tutorial sheet 8. Okay, so I'm going to upload here. Okay, once I'm done making this video, I'm going to upload tutorial sheet 10 on chemical kinetics. It's going to be there. So you can actually learn at your own time, at your own pace using our platform. Okay, so you feel free to register. Okay, you can check out the link in the description below here to know how you can gain access to all these so that it makes your academic life easier. So remember, if you are facing a challenge in math, you can still register. You're also going to find the tutorial sheet, the past papers. If it's physics, okay, you're still going to find the tutorial sheets, the past papers, as well as the biology. So you can register for the course of your choice. Okay, so thank you so much for watching, and all the best as you prepare for your exams.